Hello, we are going to review bless you, simplifying radicals. Simplifying radicals and the different myriad of examples here on how to simplify radicals. So let's do it. Now, I'm not talking about telling me that this is 4.889 whatever. That's not what we're doing. We're simplifying radicals. We need to make factor trees out of this. And this is an Algebra 2 concept, so this should be hopefully pretty easy. So you could make 2 times 12 here or 3 times 8. I'm going to do 4 times 6 because I like to try to go in the middle. That way I have less branches of the factor tree, if you will. 2 times 2, 2 times 3. We've made factor trees. You've been doing it for 5 or 6 years now, I'm sure. And what you do when you're trying to simplify radicals is you circle pairs of numbers like this. A pair of 2's under a radical makes a real 2 in front of the radical. So this is going to be 2 radical, and then whatever's left goes back underneath. So whatever is left here, 2 times 3, gets popped back under this radical. So it's 2 radical 6. So let's break that down one more step. A pair of 2's makes a real 2. That's what I claimed. If you think about the square root of 4, we know that the square root of 4 is 2. But the square root of 4 breaks down into 2 times 2. So this pair of 2's makes a real 2 out in front of a radical symbol. So that's why that happens the way it does. All right, next example. The same idea, except we have a negative sign here. And you can't square root a negative and get a real number answer. So this is going to be what's called an imaginary answer. Back 100 and some years ago, mathematicians said, well, we need to let the square root of -1 equal this thing called little I. Little I. And I'm sure you've done this before. And if you haven't really ever understood what the heck it means, that's what it means. The square root of -1 equals little I. So this right here is nothing more than the square root of -1 times the square root of positive 12. Think about it. That is the square root of -12. But since we can let the square root of -1 equal I, this is going to be I times radical 12. Now radical 12 can break down into 4 times 3, which is 2 times 2 times 3. I always like to bring all the branches all the way down. That way I have like a flat step here. And then I circle pairs. So this is going to be a 2 will come out. And the I is still out in front. So this is going to become 2I radical 3. 2I radical 3. And if you've always kind of stunk up the place at simplifying negative radicals, go back and watch that again, because this is the secret to it right here. That's the trick. I'll do it again right here. Watch. If I'm doing this, this is nothing more than the square root of -1 times the square root of 36. What's the square root of -1? That's I. What's the square root of 36? 6. Now, we don't write I6. We write 6I. So 6I would be the answer to that. And just to test your knowledge here, the square root of, say, -81 would be it would be 9I. 9I. All right. Now, what about this thing? Well, this looks like the answer to a quadratic equation problem. And you can see that the title of this is Quadratic Equations. So if you're simplifying this thing, this 48 here, that 48 needs to be simplified first. So I'll come over here and do that. 48 broken down into 6 times 8. Now, 6 is 2 times 3. And then let's just from this day forward make 8s like this. 2, 2, 2. Every time you have an 8, it's going to be 3 2's. So you got your big boy pants on. You don't need to do 4 times 2 and then break the 4 down, because an 8 is just 3 2's. And now we need to circle pairs. So I got a pair of 2's here and a pair of 2's here. So I got 2 pairs of 2's. They both come out in front of the radical and get multiplied together. So that's going to become 4 radical And then what's left? 3. So the square root of 48 equals 4 radical 3. So now back to the problem. I would replace this square root of 48 with 4 radical 3 over 4. Because what separates people who get A's on this section and people who don't is being able to simplify this, being able to simplify it. So you can start the hack and slash reducing process now, because this, and that have to have a common factor. If they all three, like this triangle right here, if they all three have a number that go into it, like 2, you can start canceling. By the way, you can never cancel this number here. Ever. That thing is like locked up in a vault. You can't cancel what's under a radical, so don't even try. If I'm reducing this by 2, this would be -3. This would be, what would that be right there? Good, 2, and this would also be a 2. So we'd write our correct answer as -3 plus or minus 2 radical 3 over 2. And that would be acceptable, although if we were, drinking tea with the pinky finger out, being proper, if you will, this could probably reduce a little bit further, because you could say this. You could say -3 over 2 plus or minus 2 radical 3 over 2, which this, and you can see that now that could cancel right there. You could cancel that and make it -3 over 2 plus or minus radical 3. So for instance, if you're taking an ACT test, for example, and you have this for an answer, but on the multiple choice A, B, C, D, and E or whatever, this is listed, you could easily think you've done it wrong, whereas you didn't do it wrong. You just didn't simplify it far enough in the way that they ask you. So you got to always be conscious of finishing the problem. But I would accept either the orange rectangle box here or this. So I'll put or right there. So either or will be fine. And you guys have a good one.